All right, good afternoon. Um, I thought I should explain this concept of divisibility using an example. This is number theory, and so there is a theorem that says if A is congruent to B under mod M, then what we know is A is equal to B plus K M, where K is an element of the integer. This is the division algorithm that was done by Euclid. I would say it's common sense as well, in a way, because all you're trying to say is, suppose you've got a number, say 8 divided by 3. So this can be written in some way as 8 is equal to 2 times 3, because there are 2 3's in 8 plus a remainder of 2. That's basically the idea. And this 2 is an element of the integer. So in the proper notation, we can write it as A is equal to B plus Km. However, that's the division algorithm. However, when we say A is congruent to B, we are saying A and B are yielding the same remainder when you divide them with M. So for example, another way of looking at it, I know this is confusing a bit. If you divide 8 with 3, your remainder is equal to 2. And if you pick another number, say 5, you divide 5 again with 3, our remainder is still 2. So because of that reason, we are in a way to conclude that 8 is congruent to 5 under what? The division of 2, because they both give you the same remainder. So there are times whereby if I'm dividing by 2, instead of using 8, I rather use 5, because 5 is a small number. So that's what the congruence is all about. Now, we extend it to the definition, because in mathematics, notation is everything. So we are saying if A is congruent to B, what this means is M. If A is congruent to B, it means M does divide A minus B. That's what it means. Which means by the division algorithm, the Euclid division algorithm, which means A minus B is equal to Km, where K is an element of the integer. And rearranging this gives us B plus Km. That's that point there I've just mentioned above. So that's very important theorem to note. And we can extend this understanding to certain truth, which I can choose to call axioms. For example, A to the power of n is also congruent to B to the power of n under the same division of m, with m as the divisor. So if 8, like in the example I just explained, if 8 is congruent to 5 under mod 3, it means even if I say 8 squared, it is also going to be this. It's going to yield the same thing under the same mod 3, because 64 divided by 3, I'll still get the same remainder as 25 divided by 3. So it extends beautifully in that way. So this is where this is mainly applied in cryptography as well. So it's a very, very necessary theorems that are very important in understanding how numbers behave in general. So we are saying, what is the remainder if I divide 343? If I divide 343 to the power 5 divided by 11, what is the remainder that I can get here? One thing we can tell is 343 divided by 5 is quite a big number. In most cases, you may not see it in the normal calculator because it's too big. So, what's the best way to do this? The best way to do this is to apply logic, which is number theory. So, if I'm dividing 343 to the power 5 with 11, I can start by checking what is the remainder if I divide 343 with 11. If I divide 343 with 11, what am I going to get as the remainder? So in order for me to find, let me just write it using the division algorithm here. To find the remainder when I divide 343 with 11, I would say 343 is equal to, I need a calculator for this, 343, how many 11s are in 343? So I would say 343 divided by 11, I get 31. So I can write 31 times 11. So that's 31 times 11. And the remainder becomes 2. So because the remainder when I divide 343 with 11 is 2, I can now conclude and say, therefore 343 is actually congruent to 2 under mod 11. That's the first step I can do. So now I've simplified this. I know the remainder of 343 divided by 11 by just using the division algorithm. Now the next step is to identify what is 343 to the power 5. It is going to be the same as this, as stated here, which is the same as just saying, because we know 2 to the power 5 is easy to find rather than finding 343 to the power 5 is 32. Still 32 is greater than 11, so we can also check what happens if I divide 32 with 11. If I divide 32 with 11, I will use the division algorithm, which is just 2 times 11 plus 10. So in other words, I know that 32 is congruent to 10 under mod 11. Now, this is less than 11. So what does that tell us? That tells us that, so 343 to the power 5 is also congruent to 10 under mod 11. Under mod 11. So therefore, to answer the question, what is the remainder when you divide 343 to the power 5 with 11? The remainder is 11, is 10. Sorry, it's 10. That is it. That is how we approach number theory in terms of division. Thank you.